Hello my dear friends, welcome to YourPedia and Engineers Career Point. So in this session you are going to discuss one of the important topic of the mechanical engineering with respect to Bharat Electricals Limited BEL exam. So here we will see some important questions from the welding, where which type of question you can expect in an exam. You know, most of the question is asked is theoretical question in BEL, and yes, you guys have a golden opportunity. So in this session we will discuss perfection through something like we will take the question and then we will discuss what is the concept behind that particular questions, and in this way we will try to cover 30-35 questions which are more important from the welding part. But yes, other than that you have to be more practice also. So but in the today we will try to cover all these important questions along with their explanation and what is the basic concept behind that. All this I will start. Okay. So my dear friends, let's start with the question number. First I am going to start this one. So this is the first question on your screen. This is the first question on your screen. The question is that in thermit welding, heat generated from option A, chemical reaction involving finely divided aluminum and iron oxide, combustion of gases, electric arc, and none of the above. So my dear friend, that question has been asked from the thermit welding. So if you talk about thermit welding, what is thermit welding? So this is basically going to used in the welding of the railway track. You might have listened. So if you have to be join the railway track, for that you are going to use the thermit welding process. And one more thing, this is on-site welding. On-site welding means in whichever is required, you are going to take that one at that particular place only. So that is called. Okay, so if you talk about from when you are going to generate the heat, so in thermit welding what is going to be happening, my dear friends, you will have aluminum powder and another one is what, iron oxide, right? These two are going to mix with the magnesium fuel, then heat is going to be elaborated, right? Here it will be Al2A3 and Fe, and after that you are going to get something is what, heat. So from there I am going to heat that one. So you can say here it will be in the powder form and iron will be there, and the ratio sometimes they are going to ask. So it will be 1:3 ratio. Sometimes that is also going to ask what is the ratio of aluminum and that of iron, then it will be 1:3 ratio. So the correct answer will be what, chemical reaction involving finely divided aluminum and iron oxide. Here you can get approximate 2600 or 2700 degrees Celsius. That is a very high temperature, right? And in this case this iron is going to be the superheated state, and after that it is happening something like this is your cylinder, something cylinder, okay, which is basically made up of ceramic. This material is made up of what, this is basically made up of ceramic, in which I am going to put the powdered form of the aluminum, and next one is what, iron, right? So let's assume that one is what, our iron is there. Okay, iron will be there, that will be in that is your cylinder. Now go to the set where you have to be perform the welding operation. I am going to put here some fuel, magnesium fuel I am going to put there, and within 20 to 30 seconds, the heat generated will be here approximate 2700 degrees Celsius, right? That amount of, and at that temperature this iron comes into the molten state, right? In fact superheated state, and after that I am going to pour whenever I have to be required to the welding, and welding is takes place. So that was the something about the thermit welding. Now come to the next question. So my dear friends, and yes, this one is the answer of that one. So we can get we can join our WhatsApp group and we will get that PDF. Next the question is the range of voltage, especially open circuit voltage in welding is generally 20 to 40 volt, 40 to 90 volt, 100 to 150 volt, and 1102 to 220 volt. What will be answer, my dear friends? So if we talk about generally the open circuit voltage which is going to used here, that will be approximate 40 to 80 volt, right? But yes, here option is 40 to 90, no problem, 40 to 80 volt, because you know if you are going to be more than that, then there will be the safety issue of the person which is involved in the welding, or welder have some issue, they might fail sometimes. So that should not be much more, it will generally kept between 40 to the 80 volt or sometime 90 volt, just for the safety of the welder. So the correct answer will be the B4 Bombay. That is a very frequent data, has been asked in different exams. Next, this is the question. Thermit welding is a form of option A resistance welding, gas welding, fusion welding and arc welding. So in thermit welding, which of the following is the type? Basically this is not a resistance welding. Thermit welding is also not a gas welding. It is not a arc welding. So what this is a fusion welding. Why? So my dear friends, if you go through the video of the thermit welding over the YouTube, you will see there something like a flame will coming out to be there, something flame like that, it is coming out to be, when obviously that will be a cylinder and this is a molten state, and if you are going to do, then it will become that one. So the correct answer will be the what? Fusion welding. You know, resistance welding, gas welding, fusion welding, arc welding. In fact, is that gas welding and arc welding itself a fusion welding, right? If you talk about gas and arc, both are comes under the fusion welding. But since the option in the fusion welding is there, so you have to be more precise, and the correct answer will be the C for Chennai is the right answer. Now come to the next question, and you have to you can see their explanation is also there. Okay, their explanation. So you can get that PDF in my WhatsApp group. Next, this is the good question. Welding spatter is welding defect, flux, electrode coating or welding technique. If you talk about welding spatter, this is also known as spatter loss. So what is this? This is a one types of what? Welding defect. First, what is the spatter, sir? What do you mean by the spatter and spatter loss is there? My dear friends, that is the one of the biggest issue, especially if we talk about the arc blow. So now you can ask, sir, what is arc blow? Because I will discuss all the things. So what is arc blow? See there, my dear friends, I am going to elaborate the arc blow. So suppose this is the workpiece and you have to be weld over that, right? And that is your electrode. Let's assume that is your electrode and it is going to connect it with the some DC power source, right? This is DC power source, minus and plus is there. So what is arc? Obviously due to the contact resistance, here arc will get generated if you make a short circuit. So this is, you will expect the arc will be something like that. You will expect the arc should be something like that. But actually what is happening? The arc is deflected from their intended path. That is their intended path, but arc is deflected. Due to why it will be deflected, I will tell you. So arc is happening something like that. Arc will be something like that. Okay. So that is the deflection. That is called is arc blow. So what is arc blow? Arc blow is basically the deflection of arc from their intended path. That is called arc blow. Now the question is that, sir, why arc blow is coming? What is the cause behind the arc blow? Yeah, I will want that it will come straight, but actually it is happening something like that. So that is arc blow. Now the question is that why arc blow is coming, my dear friends. So you know, whenever in the earlier class 9th, 10th, it might have you might have to read, or you might have been taught that whenever current is going to pass, then all around what magnetic lines of force is going to be developed, right? Suppose you know here in this current is going to be flow, so in all that what is going to be happening, a magnetic lines of force is going to be generated, right? So this black one is what? Our magnetic lines of forces, right? So what is going to be happening? You can see that in this direction more magnetic lines of force if you are going to take from that, and in this direction less magnetic lines of force. So the arc blow basically generated due to the unbalance in the magnetic lines of force. Here we can say more magnetic lines of force compared to that, and if you are going to see, so in that direction more magnetic lines of force, in that direction less number of magnetic lines of force. So due to that unbalance in the magnetic lines of force, you are going to be observe the arc blow. So arc blow is basically due to the unbalance in the magnetic lines of forces. Because of that, the arc blow is going to be observed, right? So my dear friends, so in arc blow what is going to be happening? In this case, your arc is deflected from the intended path. No, just so what is the spatter loss is here, sir? That is called arc blow. That was the cause of arc blow, and you have to make a comment how you can control the arc blow. Later on I will tell you. So my dear friends, suppose this is one of your workpiece. Okay, suppose this is to be something welded like that in this zone. So you are going to put the electrode, or this will be something like that. So what is happening? It is coming that way, no? So the molten metal from that part, so molten metal is get, suppose this one is your molten metal. Which one? Let's assume this one is your molten metal, right? So since arc is coming at the some angle, so molten metal from that part will move to that part. Some molten metal will come in the that part, not in the, this is the things that was the zone in which you have to do the welding operation. But what is happening, some molten metal comes beyond the welded part, that is the part in which you have to be joined. But some molten metal, because it is coming at the some angle, so that molten metal coming out, that molten metal coming out, that molten metal coming out, that one is coming out. So this is which is going away from the welded zone. This is away from the welded zone where the molten metal goes, and it is the one types of defect, especially that is the loss of the your material which is not going to utilize for the welding purpose. And that loss, that is known as what, my dear friends? That is known as what? A spatter loss. So that is known as what? A spatter loss. So why? So it is a one types of defect, welding defect. You have to be minimize that one. So if you talk about welding spatter, then it is what? Welding defect. Basically welding spatter is, we can say, the when molten metal goes beyond the welding zone is considered as what? Welding spatter. Now the question is that how you can overcome that one? How you can overcome that one, my dear friends? That one you have to be make a comment, right? And in the class I will discuss all this, how I can control and all this. Now suppose if I tell you how to reduce the arc blow. No, when arc blow will be 0, when arc blow will be 0, when arc blow will be 0. So my dear friends, whenever you talk about the AC source welding, AC source is there. Suppose just like this is your workpiece, okay, and that one is your electrode, and here power source is AC, right? That one is the power source. So in AC what is happening? They will change their polarity. Name is alternating current. Alternating current, why? Because they will change their polarity. So if you talk about in AC welding, they will continuously change their polarity. Once it will be something like that, then at the next instant it will be something like that, at the next instant it will be something like that. So it will get overall cancel out. So there no will be any unbalanced magnetic lines of force. So no any arc blow is observed in the AC power source. You know, their frequency is given. Suppose in AC frequency is 50 Hertz. What is the meaning of that? The meaning is that in 1 second, how many seconds? In 1 second they will change 50 times their polarity. Means in 1 second they will change 50 times their polarity. It is, when it is negative, this is positive. When this is negative, it will be positive. And 1 second it will do 50 times, 50 cycle will get completed. So my dear friends, in such case net magnetic lines of force will be the 0. So you will not find any magnetic arc blow, right? So that was the thing that you have to keep in mind. And one more thing, when you are going to be welding at the center, suppose you are going to weld at a center, that is the center, so it will be equal magnetic lines of force from both the end. In such case also you will not observe any types of arc blow, right? But if you weld at the end, either at that end or either at that end, whatever, you will observe lot of arc blow is there. So this is the two way. One thing, when we are going to welding at the center, arc blow will be minimum, impact we can say 0. When AC power source is there, no arc blow is there, right? So come to the next question. So you can see here defect, weld spatter refer to the particle of metal scattered along the this one length. Now that is the next question. The question is that two plates of a similar metal having equal thickness, right, are to be but welded with electric arc. When the plate thickness changes, welding is achieved by. When the plate thickness is changed, then how you can attain the welding? So that is the question, my dear friends. So we can say, sir, in such case basically thickness is changed, so you have to changing the electrode size, right? So when the thickness will change, you have to change the size of the electrode. If you talk about in case of what? Arc welding. So the correct answer will be D for Delhi. You have to change the size of the electrode. In fact, size of electrode, it depends upon the thickness of material which is to be welded. That types of question is going to be asked in inverse way also. That size of electrode, it depends on the thickness of material which is to be welded. So sometimes the question is going to ask like that also. So we can see that one. No, that is the next question, my dear friends. The question is that The most commonly used flame in gas welding: neutral flame, oxidizing flame, carbonizing flame, yeah, all of the above. So most of the case, the question is most commonly. The question is what? Most commonly used flame. So what will be answer, my dear friends? Natural, carbonizing, or oxidizing, or all of the above? Yes, generally I am going to use all the three, but if you talk about mostly, then the correct answer will be the neutral flame. In most of the cases, I am going to use the what? Neutral flame is going to used in most of the cases. Why? Because you know, in case of neutral flame, no excess oxygen is there, right? See there, I have taken the explanation is there also. If you talk about neutral flame, so what is going to be happen, my dear friends? In case of neutral flame, we can say neutral flame is most commonly used flame in gas welding. Neutral flame is obtained by supplying equal volume of oxygen and acetylene. There will be the equal volume of oxygen and acetylene. That's why oxy-acetylene gas welding is done with neutral flame, like mild steel, cast iron, low carbon steel, medium carbon steel, that all are. Now here it will be equal to 1 a little bit. If you talk about oxidizing flame, so in oxidizing flame what is happening? The content of the oxygen is more than that of carbonizing flame, right? The oxidizing flame is obtained when there is an excess oxygen. It is used to welding of brass and bronze, that is copper, zinc and brass can be welded by this flame. Here it will be ratio 1 to 1.5. You can say more precisely O2 upon C2H2 if rise between acetylene, basically rise between how much? 1 to 1.5, little bit, it will be little bit more than 1, then it is considered as. Next is reducing flame or carbonizing flame. So if you talk about reducing or carbonizing flame, often when there is excess of acetylene, right? When acetylene will be more, nickel L-1 high carbon steel can be welded by this flame. So here it will be the value of 0.85 to 0.95. So that is called what? Reducing flame. Now that is the next question. The ratio of aluminum and iron oxide used in thermit welding. Option A 1:3, option B 3:1, option C 1:2, and option D is 2:1. So my dear friends, aluminum will be less, iron oxide will be the more, right? So the correct answer that is possible, A is the right answer. Aluminum will be 1 and this will be 3 minutes. It will be 1 minute, then it will be the 3 minutes. So the correct answer will be A for apple, 1:3 ratio. In fact, you have discussed earlier that one. Now that is the next question. Which of the following welding a pool of molten metal is used? Pool of molten metal is used. Pool of molten metal is used. Option A is electro slag welding, submerged arc, MIG exchange force, metal inert gas, and TIG what? Tungsten inert gas welding. So in which case pool of the molten metal is going to used? So if you talk about pool of the molten metal, so the correct answer will be the electro slag. In case of electro slag welding, I am going to use the pool of the molten metal, right? So the correct answer will be the A for apple. Here pool of the molten metal is going to be used. Now see this, next question is that in DC reverse polarity welding, the workpiece is made positive and electrode is made negative. The workpiece is made negative and the electrode is made positive. Both the workpiece and electrode are positive and both the workpiece and electrode are negative. So my dear friends, if you talk, you have to be answered about the reverse polarity. Okay, so what will be the reverse polarity, my dear friends? Anybody? Workpiece is made positive and electrode is made negative, that is called straight polarity. The workpiece is made negative and electrode, suppose this is your workpiece, right, and this is your electrode. If you talk about negative, so workpiece is made up of what? Negative, this one and this. So here this is negative, this one is positive. So when workpiece is made negative and electrode is made positive, then it is called is what? Reverse polarity. Then correct answer will be the B for Bombay. The workpiece is made negative and electrode is made positive is the right answer. this is positive and that one is negative. You can say in this case how much amount of heat is going to be generated over the workpiece. So we can say, sir, here negative terminal is connected with the workpiece, so electrons will go on that one, right? Negative ions will go on the electrode and positive ions come on the workpiece. So which one have high kinetic energy, my dear friends? We can say, if you talk about kinetic energy of electrons, then that will be our negative ions, half mv squared. So my dear friends, which one have high velocity? So we can say which one have high velocity. So obviously electrons is moving in that way, so electron have high velocity, right? Or negative ions have high velocity. Here negative ions is going to strike over the electrode. So what is going to be happening? Whatever they have energy, that gets converted into the heat energy. Whatever kinetic energy electron have, that will gets converted into the heat energy, and due to that, since huge kinetic energy is there, so whatever total amount of heat is generated, their 2/3 will be over the electrode. That means, so whatever, suppose if 300 unit heat is going to be developed, let's assume 300 joule, right? That means 200 joule we go over the electrode and 100 joule will go over the, you can say, workpiece, right? So huge amount. So here you can say some more deposition rate will be there, right? Because huge amount of heat is generated over the electrode, so high heat is developing, so more deposition rate can be. So sometimes that question is also going to ask, then in reverse polarity what will be the deposition rate? It will be the very high deposition rate. But if you talk about a straight polarity, my dear friends, so coming to that one, suppose that one is our workpiece and that one is our electrode, and this is something like that, okay? That is positive terminal and that one is negative terminal. So we can see here here what is happening. So positive ions goes like that, okay, and negative is coming on that. So negative is coming over the electrode, so 2/3 of heat will generate over the workpiece and 1/3 will generate over the electrode. Why? Because here negative ions strike on the workpiece. This is your workpiece, and you know workpiece is what? Whatever they have kinetic energy will gets converted into the heat. So electrons have high kinetic energy. Why? Can anybody tell me why electrons have high velocity? In fact, a student, most of the time I have seen a student is going to confuse, sir, kinetic energy half mv square, right? Yes sir, but sir, I know mass of positive ions is that of mass of more than that of negative ions, sir, more than that of negative ions. Yeah, you are right. Still you are going to say that kinetic energy of negative ions is more, because mass of positive ions is high, sir. So why? So you have to make a comment why the kinetic energy of negative ions is more. What is the cause? Impact the mass of less than that of positive ions of the negative ions. So you have to be answer that one in the comment box, and I will reply that one. Okay, so come to the next one, my dear friends. So that was the answer of that question. Which of the following welding process uses consumable electrode? Which of the following uses what? Consumable electrode. TIG welding, MIG, MIG welding, thermit welding, or gas welding. So uses consumable electrode, right? Here electrode is what, my dear friends? Consumable. So which one process you are talk about? Consumable electrode. So in thermit welding, if you talk about, no, here no electrode. Gas welding, if you talk about, now if you talk about TIG, it is called non-consumable electrode. Why? Because in case of TIG you are going to use the as electrode is tungsten, and tungsten have high melting point, so it will not consume. Yeah, it can diffuse, but it have not a consumable. But if you talk about MIG, so here electrode will be what? Consumable. Here electrode will be what, my dear friends? Consumable. So the correct answer will be B for Bombay, in which I am going to use the consumable electrode. So if you talk about tungsten, if you talk about TIG, tungsten inert gas welding, my dear friends, here you are going to use the, what is more important point that you have to be keep in mind? In case of TIG, you are going to weld for that material having less thickness. Why? Because here consumable, here non-consumable electrode is going to be used. You can see there, this is your workpiece, Okay, the electrode is non-consumable. Electrode is what, my dear friends, here? Non-consumable. So electrode will not consume. So if the heat will go over that one, if the heat will go over the electrode, or that is the tungsten, so what is happening? Their temperature will rises up, and you know, if temperature will rises up, then what will be current carrying capacity? If temperature rises, what will be current carrying capacity? So we can see, sir, if temperature rises, the current carrying capacity decreases. So here high amount, it will not going to be consumed, so their temperature rises continuously, my dear friends. That's why you are going to use the water jacket is there. That's why you are going to use what? Water jacket. So here I am going to give the water jacket, so that their temperature remains in the balance, otherwise it will loss of energy. So my dear friends, can you tell me, here is it feasible to use the straight polarity or reverse polarity? Which polarity is good here? So you talk about, if you say, sir, if I am going to use the reverse, if I am going to use the straight polarity, that is the straight polarity, so more of the heat is generated over the workpiece, more of the heat is generated over the workpiece. But suppose if you are going to use the reverse polarity, so huge amount in, if you are going to use in case of TIG and polarity is reverse, like that, this one is your electrode workpiece, this one is electrode, and you are going to be use something like that. Okay, that one is positive, that one is negative, like that, that one is your DC power source. So what is happening? 2/3 of heat is generated over the electrode, 2/3 heat of generated over the electrode, and if 1/3 was there, you have to use the water jacket. If 2/3 will be, it will be very, very dangerous. There some problem is that this tungsten will diffuse over the workpiece, so that makes the brittle. So we can say, sir, reverse polarity is never preferred in case of TIG, unless and until not required. I will never prefer. Now my dear friends, tell me, you have two things, one is higher power source, another one is lower power source. So which one power source is feasible here, higher power source or lower power source? We can say, if there will be higher power source, my dear friends, if you are going to use the higher power source, then what is happening here? Huge amount of further heat is generated. So again, that's why in generally I am going to prefer the lower power source, and that's why if the power source is low, then you can weld a thin material. Here maximum thickness that I am going to use 5 or 6 mm material. In such case I am going to use the TIG, and this is also for those which is highly refractory or highly reactive in the nature, like aluminum. Aluminum is going to be welded by the what? TIG, right? So that thing you have to be keep in mind, non-consumable and consumable. So answer is A for apple is the right answer for that one. B for Bombay is the right answer, consumable. Next question. If the proportion of oxygen is less than that proportion of acetylene into oxy-acetylene gas welding, then the flame. Proportion of oxygen is less, right, than that of acetylene. So it will be the carburizing flame. Means if acetylene is more, then it will be what? It will be the carburizing flame. Here we can see from the question very clearly mentioned. Next, here resistance spot welding is performed on two plate of 1.5 mm thickness with 6 mm diameter electrode using 15,000 ampere current for a time duration of 0.25 second. Assuming interface resistance to be 0.001 ohm, the heat generated in the form of weld. Okay, so my dear friends, that type of numerical we can expect, because that is totally formula based numerical. You don't have to do more things. Little bit such type of first thing numerical will not come, but if coming in your exam, then that will be totally formula based. So you know, heat will be heat will be I square RT, right? I have come with the solution, you can see here, given thickness that one. So heat generated from the weld is I square RT. So I square RT by the just make a calculation and you will get 5625 watt per second, 5 watt second, right? So simply that thing you will get, right? So no need to be worry about that, my dear friends. Simply you are going to get that one. Next, TIG welding is preferred for TIG, tungsten inert gas welding is preferred for mild steel, aluminum, silver, or option are correct. For which case you are going to prefer the TIG? Anybody? What will be the answer, my dear friends? What can be the answer? So if you talk about TIG, just now I have told you, you have to go with the aluminum. So you can see now welding a stronger weld, you see TIG welding for thinner metal, as I told you, it makes a much stronger weld. TIG welding create a stronger bond. Another reason why it's preferred for the aluminum and stainless steel. This all are stainless steel is there. Next, in oxy-acetylene gas welding, the volume of oxygen required per unit volume of acetylene. In oxy-acetylene gas welding, the volume of oxygen required per unit volume of acetylene means if you have 1 unit of acetylene or 1 mole of acetylene, then how much mole of oxygen required to complete combustion of 1 mole of acetylene. So that question has been very frequently asked in different exams. So just I have made one calculation, and through that you can understand that one. So my dear friend, that is the relation which is going to be F here, C2H2 5/2, then it is from 2CO plus H2O. So 1 mole of C2H2 required 5/2 mole of 5/2, you can say 5/2 implies 2.5 mole. So we can always keep in remember that 1 mole of oxygen, 1 mole of C2H2, 1 mole of C2H2 is always required 2.5 mole of O2 for complete combustion, right? For complete combustion. So that was the question, and that was the good question, has been asked in different exams. So the question is here, you can see in oxy-acetylene gas welding, the volume of oxygen required per unit volume of acetylene, then the correct answer will be the 2.5 is the right answer. That question has been asked in various times, so try to be remember. Here a student is going to be confused, they are not going to ask about the it is oxidizing or reducing or carbonizing or neutral, whatever, that is not going to ask here. Only going to ask how much amount of oxygen required, so it will be 2.5. Okay, so that is the next question. The welding is set up to have a straight polarity. I think that we have earlier discussed. So work is connected to the positive terminal, electrode holder to the negative terminal. Yeah, that one is the right answer. Yeah, work is connected to the positive terminal, electrode is connected to the negative terminal is the right answer. Okay, and yes, my dear friends, we can join our batch which is running, which is dedicated module for BEL. In this we are going to discuss the theory as well as numericals, important all these. So you can join our session, or you can join the module. So we can see here straight polarity is the right answer. Next question, in which of the following welding process flux in the form of granulars is used? So if you talk about flux in granular, then the correct answer will be the submerged arc welding. If you see in submerged arc welding, in fact sometimes the question is going to ask in which have highest thickness arc welding should talk about. So which welding process can join the highest thickness, then it can be the submerged arc welding. There is no any issue of the spatter loss is there, zero spatter loss, because here arc is submerged, right? Here we can say this is your workpiece. So here arc is in that zone, here it is submerged in that, so no any spatter loss is there. Sometimes they are also going to ask in which zero spatter loss is there or zero spatter, then it will be the submerged arc welding. So here the flux is going to be used in the grain, you can say in the very powdered form, but yeah, that have one of the disadvantage that controlling of the flux material is one of the very difficult task, sort of a task for the submerged arc welding. Here it will be submerged, right? Here arc is what? Your arc is submerged, that's why it is known as submerged arc welding. The major difficulty during the welding of aluminum is due to, okay, what is the major difficulty when you are going to do the welding of aluminum? What is the major difficulties, my dear friends? Anybody? So we can say high tendency of oxidation, high thermal conductivity. No, they have one of the various issues there, out of which one of the issues is that they have, you can say, high tendency of the oxidation. That is the one of the major difficulties associated with that one. So we can say aluminum is very difficult to weld because it forms a layer of Al2O3 on the surface. Major difficulty doing the welding of aluminum is due to its high tendency of oxidation. To avoid this, TIC welding is used for the aluminum. To avoid this, you are going to use the TIG, tungsten inert gas welding, known as non-consumable. Arc welding also non-consumable electrode is used here. Now see there, arc blow encountered in AC welding machine, DC welding machine, thermit welding, none of these. So what can be answer, my dear friends? Tell me, what can be answer of that one? Anybody? So we can say arc blow encountered. Also, if you are going to use the AC welding machine, that I have earlier discussed, in AC welding machine you will not get any arc blow. You are not getting any arc blow because there is net magnetic lines of force will be 0. So you are not going to get any arc blow in AC arc welding. Just now you have discussed, right? So what was the question? Correct answer will be A, no issue. In AC arc welding you will not find any arc blow. DC you will find the arc blow. Next question. What is the type of shielding gas, GTAW, gas tungsten arc welding, used for carbon steel only called? For carbon you are going to use the argon. Helium and argon basically going to use. So if you talk about the shielding gas, basically here in the option, so youth option, the correct answer is what? Argon gas is used. So we can see their explanation. Now next question is that submerged welding is what? What is the submerged welding? A process which uses the mixture of iron oxide and granular aluminum, accomplished by maintaining a hot molten pool between plates, a process in which arc is maintained under the blanket of flux, or all of the above. So what will be answer, my dear friends? Anybody? What will be the correct answer for that one? So we can say, sir, I am talking about submerged, right? So in submerged, what is happening? The arc is maintained under the blanket of flux, right? So the correct answer will be C for Chennai, a process in which the arc is maintained under the blanket of flux. So C is the right answer. The material used for coating of electrode. Suppose this is your electrode and you have to coat for that. So for coating, which material you are going to use? So we can say, if I am going to use, then the material which is going to use for the coating, that is known as what, my dear friend? Flux. The material going to use for the coating of electrode is known as what? Simply we can say flux. This is known as what? Flux. So that thing you have to be just keep in mind. So now this is a question. In submerged arc welding, arc is produced between. In submerged arc welding, arc is produced between carbon electrode and the workpiece, metal electrode and the workpiece, bare electrode and the workpiece to tungsten. So correct answer will be here. We can see I have come with the option with the answer. C is the right answer. In submerged arc welding, common arc welding is produced, that is involve the formation of an arc between continuously fed electrode and the workpiece. So the correct answer is what, my dear friends? C is the right answer. Now, which of the following is a fusion welding process? Which of the following is a fusion welding process? forge, gas, resistance, thermit welding with pressure. The more precise will be the gas welding. Okay, otherwise you can go with the thermit welding, no, but the will be the what? Gas welding. Which the color of oxygen cylinder in oxy-acetylene welding is? That is the very frequently question has been asked. What is the color of oxygen welding and acetylene cylinder? Oxy-acetylene welding, what is the color of oxygen and acetylene? So if you talk about here, oxygen cylinder is going to ask. So during COVID time you might have seen the color of the oxygen cylinder, then it will be the black. But if you talk about acetylene cylinder, then it will be the maroon. Try to be remember. Maroon, acetylene, why maroon? It is something looks like very close to red, na? So maroon, this acetylene is very harmful, right? Even it can explode due to its self weight. So red is the sign of danger, na? So maroon or red color is going to for the what? This is for the acetylene cylinder. Acetylene cylinder. If you talk about that one, black for the oxygen cylinder. Maroon, right? Okay, that is the last question for today's discussion. Type of oxy-acetylene flame tend to reduce the its strength and ductility of weld metal, also make it more brittle. So carburizing, you know, in carburizing what is happening, they have huge amount of carbon, more unburnt carbon is there, so it may go to the workpiece. If they will go to the workpiece, if carbon content increases, it will makes brittle, right? In any steel, if you are going to increase the carbon content, then it will be brittle. So carburizing a flame, even increasing the breathability or ductility or decreasing the ductility. So my dear friends, that all are about the today's session. So when we will meet in the next session with some more question on the welding on other subject, and you can join our module which is running, right, for more practice session, getting more insight all these on, and for getting a test series that will also very crucial. You can join with us. Thank you my dear friends, we will meet in the next session.